Hello all, welcome back to my channel Gateway to Computer Science. Today we will be discussing about the various factors that actually define which kind of scheduling algorithms can be used for various processes. Okay, so we have various kinds of times which determine what kind of scheduling algorithms can be used for processes so that it can go and execute on CPU. So as we already know, what happens basically is when the process is created, it will be new state and then it will be sent to the ready state. In ready state, using the operating system uses this scheduling algorithms to schedule the process so that it can go into the execution, that is the running state. So there are various factors such as arrival time, burst time, completion time, turnaround time, etc. that will determine what kind of scheduling algorithm can be used and all of it. Now we'll be discussing about it. This is very important for you to understand so that you will understand the scheduling algorithms in a better way. So just pay attention to this. And yeah, if you haven't subscribed to my channel yet, I would request you to please subscribe to my channel. And let's continue with today's topic of discussion, okay? So first we have this arrival time. Arrival time is basically the time at which the process enters the ready queue. See, let's understand with the example of, like for example, if you want to open a bank account, okay, now you are going to the bank to open the bank account. So arrival time there will be the time at which you went to the bank, okay. And then you have burst time. Burst time is the time required by a process to execute on CPU. Now you will go to the bank and in your mind you have thought that okay, this much time will be required for me to do the whole process of opening the bank account. So the time that takes for you to open the bank account that actually is required to open the bank account is the burst time. So the time required by a process to actually complete its execution is known as the burst time. Then you have completion time. Completion time is the time at which the process completes its execution. See, you shouldn't get confused between the burst time and completion time. They are totally different. Burst time is the time you actually require to complete the process, but completion time is the time when you actually completed the process. See, in between, for example, if you go to the bank, there can also be other people who are near the administrator. As soon as you enter the bank, there are no chances, there are very least chances that you will get the administrator and you can do your process done. There will be some other person who will be waiting there, or if you go at the timings which are during lunch or break, then you'll have to wait till they complete their lunch or everything. So as soon as you go, you won't get your things done, right? So burst time is the actual time required and completion time is the time at which it completes its execution. And then we have turnaround time. Turnaround time is like you can take the completion time minus the arrival time. That means the time you spent in bank, okay, the time you had to wait and get your process done is the turnaround time. The time that you have spent in bank is the turnaround time, okay. Then you have waiting time. Waiting time is turnaround time minus the burst time. That means the time you had to wait. Waiting time will be the turnaround time minus the burst time. That means the time you have spent in bank minus the time it takes for you to get your things done. So the rest of the time you had to wait. So that is the waiting time. And then next we have response time. So the response time is the time at which you actually get the response. Okay. The time at which the CPU is given to the process minus the arrival time. From the time you have arrived, at what time you got the response from the bank people is the response time, okay. So let's understand with the Gantt chart. Gantt chart is one of the representation for you to understand this processes very well, that you will understand it more properly when you will be solving the problem. Here I'll just show you, okay, how it is. Now see, this is your table where you have three processes, P1, P2 and P3, okay. And see, always arrival time will be given, the time at which the process enters the ready queue, and burst time is the time that actually takes for a process to complete its execution. Now P1 needs 2 seconds, to complete its whole execution. That means it needs CPU for 2 seconds. Now P2 needs CPU for 1 second and P3 needs CPU for 2 seconds. Okay, and arrival time is the time at which the process actually enters the ready queue. So from ready queue only the process gets scheduled and then it enters to the running queue, running state. So P1 arrives at 0 seconds and P2 arrives at 3 seconds and P3 arrives at 4 seconds. So this is the question. So we will just solve this with the help of first come first serve scheduling algorithm. So that is like whichever process will come first will get the CPU first, and it is completely based on the arrival time. Okay, we will understand this properly with one proper example in the further videos. Now for us to understand how the Gantt chart is actually represented and how you will actually calculate all these times, for that we will just understand this. Okay, see here P1 arrives at 0 seconds, so P1 will be first given to the CPU. Okay, and its burst time is 2 seconds. So for 2 seconds the P1 will be getting executed in the CPU. Okay, for 2 seconds the P1 will get executed in the CPU. Now see, the P2 process comes at 3rd second, but P1 has actually already completed its execution at 2 seconds. So what we'll do is, for 1 second the CPU will go into the idle state because there are no processes present in the ready queue. So what will happen is, for 1 second the CPU will go into the idle state and then at 3 P2 enters. Okay, and then it will complete its execution for 1 second. Okay, and then P3 is already present at 4th second, so P3 will come into the running queue. So Gantt chart can be the representation of your running state. Okay, how all of it is getting done. Okay, P3 will enter at 4 seconds, so its burst time is for 2 seconds, so it will get executed for 2 seconds. Now this is how the Gantt chart representation is. Okay, now see, the completion time of P1 will be 2 seconds, P2 will be 4 seconds, P3 will be 6 seconds. Okay, the time that was required is very different from the time it actually gets completed. Okay, you shouldn't get confused between the burst time and the completion time. Once you calculate the completion time, then you can calculate the turnaround time, waiting time and response time according to the formula. We will see that in further videos, and we will see that particularly for various algorithms. Okay, and this is the actual representation of the Gantt chart and how the things are getting done, so that it will be easy for you. When you will represent it in this form, you will not get confused and you will understand it in a better way. Okay, arrival time will be towards the left side. Okay, arrival time of the process, and completion time will be towards the right side of the process. Okay, and in preemptive algorithms there can be chances that the processes can repeat itself in the Gantt chart and the completion time can vary. You will understand that in the further videos where I'll be explaining each of the scheduling algorithms. Okay, our next video will be on first come first serve algorithm. Okay, just pay attention to this. It's very easy. If you understand all of these things very well, then it is very easy for you to even solve the problems related to this. So I'll be making the video next on first come first serve algorithm. Just stay tuned, and if you haven't subscribed to my channel yet, just subscribe. And if you find this information useful, please like and share this video amongst your friends. Thank you for watching and have a nice day.